Hello, this is Taeyong from MIDAS IT. How are you today? I hope all is well and thank you for coming. And also, I really appreciate taking your time. Today's subject is about dead loads. The dead load is used as one of design loads when an engineer designs a structure. And many analysis software provides essential functions to consider dead loads. Those are frequently used and it commonly contains handy options. Therefore, I'd like to give you some information about dead loads, related functions in MIDAS Civil, and some applications that contain dead load cases. Please feel free to watch this webinar. Here are contents that I prepared. First of all, we will see what functions are provided to consider dead loads in MIDAS Civil, and I'm gonna give you a short description to you. After that, we will see several application models that have dead loads. Let's see what functions does MIDAS Civil have for dead loads. What are dead loads? The dead load is one of the design loads in several design codes for structures. The dead load is the load that makes permanent deformations at structures during service period. The weight of structures or attachments on structures are common case of the dead load. For instance, in a building, the weight of a loop, walls, floors, columns, attachments, and etc. can be the dead load. In a bridge, the weight of a girders, slab, or deck, a pier, an abutment, a pavement, and other attachments can be the dead load. Let's move on to MIDAS Civil. MIDAS Civil provides a static loads functions group. You can see it under Load tab here. Static loads functions group has self-weight, nodal loads, beam loads, and pressure load functions. Those can be used to consider dead load. We can define a load case using this procedure. First, select static loads group under Load tab. Second, click Static Load Cases function and define a load case. Lastly, select a load function that we want and define all detailed information in the load case. Now, we will walk through those functions that I mentioned. First one is static load cases function. Before we use each load functions, we should define a load case via static load cases function. While running analysis, software will perform static analysis for each load case. When a load case is defined, we should select a load type here. So there are so many types prepared, but those are used when we use auto load combination functions in the load combination function of MIDAS Civil. Therefore, if you don't use the auto load combination function, it is not mandatory to select exact load type. So you can select one that you want. Now we will see each load functions. So first one is self-weight function. Through this function, we can consider the weight of a structure easily. The self-weight is calculated with the volume of a structure, weight density defined in a material property function, and the scale factor defined in this function. If the shape of a structure is not complex, uh, we can compare analysis results and our hand calculation. Next, next one is nodal load functions. This function applies point loads to nodes of elements. Available load types are actual forces and moments. The direction of loads follows global coordinate system. And next, these are element beam load function and line beam load function. These functions apply point loads and distributed loads to beam elements. So, is it possible to apply this function to truss elements? The answer is no. The loads can be applied to nodes of truss elements. So we can find the marked difference between two functions in this figure. So I assume the load type like this. So the beam if so the element beam load function applies the load to each beam element. So we can see each element has each load type, but the line beam load function considers assigned several beam elements as one element when it applies a load, like this. And this figure shows available load types in two functions. We can apply loads with exact location and amount of forces to consider that loads. The location of loads can be determined using the ratio or a ratio of length or actual length. And especially if we select pressure load type, we can apply pressure loads to beam elements. Applied pressure load will be recalculated as the uniform distributed load considering the width or height of a section. So this case I applied the 5 kilonewton per meter square pressure, but the the software will consider this load as a distributed load using this height. So the formula is like this. So the software will calculate that this element has 10 kilonewton per meter. Therefore, if pressure loads are provided as a design load and you have beam elements as a model, you can use this function without additional calculation for input. Next one is pressure load function. This load type can be applied to plate elements and surfaces of solid elements. There are two ways to apply the pressure load. The first way is to use define pressure load type option. Here we can define up to 8 load cases and apply all load cases to the same elements at once. So in this figure we can see the two load cases defined, and these load types was applied it to the plate element. So after applying, oh, we can I can see this applied load on the plate elements. And the second way is to apply the pressure load to elements directly. We just select a type of pressure loss and apply it to elements selected. So in this case, we don't need to define the pressure load type in advance. And this is hydrostatic pressure load pressure function. We can apply triangular shape or non-uniformly shape of pressure more easier than pressure loss function. This function can be used to consider the soil pressure or water pressure. And the last one is plane load function. This function applies a load type defined in advance to assigned plane. If there are elements in the assigned plane, the load will be placed on the elements. The highlighted things is that plane load type can be applied regardless of mesh plan of elements. So before we checking application model, let's see the demonstration with MIDAS Civil. Okay, I prepared the one beam element model. I will copy that. So I think I need one more beam element here. Okay. So let's see Nodal Load first. So move on to the load tab and we can see the static loss here. And there is the static load cases function. So we need if we before we create the load case load information, we need to define a load case in the static load cases function. So click here. So there are 4 cases now. So if you want more, just input name and select the load type. So we should select the load type at least one. So there are so many types you can see, but each load type will be used for the auto load combination function. So if you don't need that, you just select the user defined load like this. And you can, and also if you want to see the auto load combination function, you can see that under the ledgers tab there is a load combination function and it has auto generation option. So through this option you can define an auto load combination as per each design code. So close that. Yeah. First of all is self weight. So click the load type and here you can see the load case defined. So select the LC for instance and input factor scale factor. So and if you click add, you can see the added load case load type in the LC load case. And let's move on nodal loads. So as you know, nodal loads can be applied to each nodes of elements. So in the same manner, select the one load case and input the value to each component like this. And as you can see, you can input the minus or plus unit. So it means the direction of forces. So you can control the direction of forces using the plus or minus. And select node here like this. So after applying load information, and if you want to see the where the load applied just it is quickly, so you can see the load case in the work tree, and there are some load name. So if you right click here, you can see the display on display. So just click display. You can see the direction with the values of a load, and if you don't want to see that, just click on display. Yep. And next one is element and line beam load. So first one is element load. So there are eight eight types of load here. So I will use a trapezoidal load case here, and you can see the value and the relative and absolute. So these mean the method to define the location of load. So relative means the using the ratio of lengths, and the absolute means the using the absolute direction, absolute location. I mean, so I will use relative. So I just input the ratio of length. After that, select element. So as you can see, the same load will is assigned to each element, but I selected line beam load type here, and I will input same value. And define the line, just clicking the start point and the end point like this. And then you can see the applied load here. So this is difference between the element beam load function and line beam load function. Okay. And let's input the pressure load. So I think I need the plate element, so we can create the plate element easily. I just used extrude function. So through this function you can get the plate element from the frame type, so like this. So we got plate elements here. and move on to pressure load. So there is two type. One is defined pressure load type, and one is the assigned load type. So if you select the assigned pressure load, you can define the pressure load directly to plate elements or surface of solid element. So there is the load type. First of all, select the load type here, and then select the load type, and I selected a load case, and input the input value for load, and just select element and click apply. And I will use define pressure load type to the various pressure load to the same element. Okay, so first of all, input name of the load group, and select the load case. Sorry, and there is two type for loads. The first one is uniform, and second one is linear. So uniform means that uniformed pressure type, but linear means we can control the load value for 4 point, and click add to apply to define the pressure load, and move on to the assign pressure loads again. And there is the type in the pressure load. So if you select load type, you can see the load type we defined. So here, if you need more, just click the dot 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 button. You can define more here, and we just select element and click apply, so we can see the applied pressure load type. Okay, and the next one is the hydrostatic pressure. Through this function, we can define the triangularly shape of pressure or non-uniformly shape the pressure more easier than the pressure load function. So there are two types, the curved loads and the linear loads. So these functions commonly used for the soil pressure and hydrostatic water pressure. So let's try. So first of all, select the element type. So we have plate element now, and select the load direction. So I will use the local jet. So to check the local direction of element, move on to the display function, and here is element, and you can see the under the element tab there is a local axis. So if you click and apply, the local axis will be shown. Let's see. So first of all, select the direction of of a load, the depth. So I will select X direction, and select the reference level and input some value, and select element. After that, click apply. So you can see the applied load like this. the last one is plane load. So in the same manner as pressure loads, we can define the several plane loads in advance, and also we can define directly here. So first of all, click the define load type. So I prepare three load types. The first one is point and second one is line. These three will be the load type, and third one is the pressure load type. And move on to the assign plane load. In the same manner, we need to select the load case, and under the load group name you can see the plane load type. So there are three type we prepared. But if you need more, just click this button, and after that select the element type. There are two types, plate or solid, and this is the most important part of this function. So loading place, so we need to define the a plane to apply a load. So to define the plane, we just click three point, so origin point, and click the second point to define the x direction, and click the third point to define the y-axis. And after that we can control the load direction and projection here, and just click apply button, so we can see the applied load. So in the same manner, we just change the load type and click apply, and click apply. So we can see the three load type on the plate element using plane load type. Okay, let's go back to the presentation. So we saw various functions in static load function group in the previous slides and the demonstration. Now we will see application models with dead loading. The first application is about self-weight. Self-weight load can be used to the various structure models. The major reaction of structures against self-weight load shows the deformation toward the direction of gravity as shown in the figures. The second application is about nodal loads. The nodal loads can be used to consider the weight of devices for construction. So the devices could be a derrick crane, a lift crane, and foam traveler, like this. So these are the foam traveler. For instance, in this figure, the weight of foam travelers and eccentricity loading of foam travelers are considered as a nodal loads, like this. Here, nodal loads are applied in the transverse analysis for a concrete box girder model. The nodal loads function is used to consider the vertical component of pre-stressing loading and the wind load on barrier. So these are the nodal load for each load case. And these example models are plate and solid models for a pier. Nodal loads are considered to apply the weight of support structure to the top of a pier. So you can input the load using the nodal loads to each node directly. And the third application is about beam and line element loads. In this example, beam loads are applied to grillage models for girder model. During construction stage analysis, beam loads are used to consider the weight of wet concrete for the slab on girders. And here, beam loads are used to consider wind loads on bridges. The wind loads are calculated individually and it is applied using beam load function. In these applications, beam loads are used to consider additional dead loads such as barriers, pavement, and other attachments. Additional dead loads can be applied individually to their location of a model, or it can be applied as total value. So these are the summation value of dead load. In this case, the dead load is applied to the proper location. And next model is a culvert with beam loads. The culvert is modeled with beam element as a unit length 1 meter. Therefore, beam elements are applied to consider external loading. The external loadings such as soil pressure, water pressure, and live loads are applied using beam load functions. And this is last application models. It is regarding pressure, hydrostatic, and plane load functions. These example models consist of plate elements and solid elements. The pressure loads are used to consider the weight of pavements, barriers, and additional attachments. And if you have the solid element, I think the pressure load type would be the better way to input the load on the solid element to avoid the concentrated the stress or load results. And these models are an integral bridge and a culvert that contains plate element. Here hydrostatic pressure loads function is used to consider soil pressure and water pressure. The last model applies plane load function. This Gordon model has plate element. When messing this model, it doesn't consider loading location. Therefore, plane load function is used because plane loads can be applied regardless of the location of nodes. So each figure shows the loading state for each dead load case. Yep. So we have looked into dead loads and related functions in MIDAS today. I think today's topic might be not that interesting for engineers who are familiar with FEM software because we had basic items. Our team will return with more advanced items later. So if you have any question, please write your question and your opinion on the question board. So we will have short question and answer session and then wrap it up. So thank you for coming again. I will give answers on the MIDAS Academy blog after this webinar. See you. Bye.